What did you learn last year about slope? There were two R words, something over something. Rise over run, does that sound familiar? Yeah, did you learn that last year? How many people have heard rise over run at some point in their life? You did not enjoy it? Okay, well, we'll hopefully improve on that this year. Did we talked a little bit about y equals mx plus b last class? Do you know which of those letters represents the slope? Is it the m or the b? M is the slope. Yep, and b is the y-intercept, and we'll get into that later. But today we're focusing on slope. How about this? Can you guys show me? So take your pencil and hold it out in front of you so that it's horizontal. Hold it out in front of you. Hold it up so I can see it. So it's horizontal. Can you make that pencil have a positive slope? What would it look like if it had a positive slope? Show me so I can kind of see. Would it be going like this, or would it be going like this? What do we think? For a positive slope? Yeah, you guys are doing pretty well there. So a positive slope would, remember with a positive slope, we kind of think about somebody walking up of it from left to right, and if they're going uphill, that'd be a positive. This would be a negative slope. Cool. Okay. Well, let's get into it. We're going to just go over a couple examples here in the sheet, and then we'll add some notes to our packets. You guys are actually going to have a pretty good chunk of time to start on the assignment today. Hopefully finish it before the weekend. All right. So, what I need you guys to know is that slope, which we often abbreviate as M because slope, right? It's pretty obvious. Actually, I have no idea why they use M for slope. I feel like we looked it up once and there was a reason. Because they'd used all the other letters for something else. Could be. I need you to know that M is change in Y over change in X. The little triangle symbol there means change in. It's actually not a triangle, it's the Greek letter. Does anybody know what Greek letter that is? What is it? Beta, close. It's delta. Yeah, it's delta. So delta y over delta x, but that Greek letter delta in math means the change in. How much did the y change? How much did the x change? So I want you to think about these 2 points that are on this line. And we're going to draw what's called a slope triangle. If you guys would, can you darken in these couple of lines here? I'm actually going to shade it in. Feel a little artistic today. Now, when I go from that one point to the other, both my x values are changing. Remember, x goes from left and right. And my y values are changing. How much is my y value changing when I go from this point to this point? In the y direction, how much am I changing? I'm changing by 27. So for this one, it would be 27 on top, because that's how much my y is changing. How much is my x value changing as I go from this point to this point? It's changing by 3. So my slope, change in y over change in x, is going to be 27 over 3. And we can simplify that, right? What is 27 divided by 3? 9. So our slope is 9. There are some times when we will write it as a fraction. Do you all know how to turn an integer like 9 into a fraction? It's really simple. What can you put underneath it? And put a 1 underneath it. So sometimes we'll call that 9 over 1. All right. Let's see if we can do one here. Oh, they didn't give us any numbers this time, but that's okay. We can count. So let's figure out what our change in y is and our change in x. We'll put the change in y on the top, change in x on the bottom. So count for me and make sure you're counting spaces and not lines. What is my change in y? So remember the y value is going up and down, so my change in y is 2. So I'll put that on top of my fraction. And what about my change in x? How far am I changing in the x? 1, 2, 3, 4. So change in x is 4. So 2 over 4 for my slope. And I think we can simplify that, can't we? What can we divide both 2 and 4 by? They're both divisible by 2. Let's simplify our fraction by dividing top and bottom by 2. That's going to get me 1/2 for my final slope there. We're going to skip number 16. How you guys feeling so far? Just kind of coming back. Do you remember doing something like this maybe a little bit last year? Some people, yeah, some people not so much. That's okay. That's okay. If this is the first time you've seen it, we'll take it nice and slow. We're actually going to spend 2 class periods on slope. So today is just a basic intro. We're going to practice this a whole bunch next Tuesday. What is that? So in this one, we've got 4 different lines. Oh my goodness, this is the back side. Oh, it's going to be fine. This is going to be a blast, guys. Settle down now. Settle down. Hey, look at those 4 lines and tell me, do any of those lines have positive slopes? Give me a letter of a line that would have a positive slope. You think C has a positive slope? If I were standing on C and I were walking from left to right, would I be going uphill? Absolutely, that has a positive slope. Let's put a little plus next to it to remind us of that. What other line here has a positive slope? B has a positive slope. Ooh, yeah, that's a steep one too, isn't it? Any hikers in the room? You guys like hiking, backpacking? Yeah, that would be a pretty gnarly trail to be trying to climb up, especially with a backpack. But that's definitely a positive slope. You think A has a positive slope also? If you were hiking this from left to right, you'd be going uphill. Yeah, A is definitely a positive slope. Not D though. What's up with D? So if we were going from left to right along D, we'd be going downhill. D has a negative slope. In a minute, we're going to find the fraction for D. We got to make sure we put a minus out in front of it because it's a negative slope. So when you're backpacking, would you rather go uphill for a really long time or downhill for a really long time? What do you guys think? You'd think you'd want to go downhill, but I'm with you. I'd rather climb it twice than have to go back downhill. Downhill is painful. Your feet hurt and your knees hurt. You got to put your heels in, but if you're carrying a backpack and you got all that extra weight, like just it's so much like you're just pounding on your legs when you're going downhill. It's really painful. When you're going uphill, your muscles get sore. When you're going downhill, your joints get sore, and it's easier to deal with sore muscles. Anyways, I'm with you. I'd rather climb it twice than have to come back down. All right. Let's find some values for these. So we're going to do some slope triangles. We got lots of choices on A. They were even nice enough to draw some little itty bitty slope triangles. So pick one of those out and highlight it, and let's count our change in X and our change in Y. So change in X goes left and right. How far are we changing? It looks like just 1, right? And then same thing for a change in Y. So when we do our slope here for A, our slope is going to be, you said 1 over 1? Yeah. And we could simplify that. What is 1 over 1? That's just 1. All right. Let's pick one of those triangles for B. I'm going to go for this one. All right, so my change in X is 1 again, but my change in Y is 1, 2, 3 spaces. Again, make sure you're counting spaces, not lines. Count spaces. So my slope for B is going to be, is it 1 over 3 or 3 over 1? 1 over 3 or 3 over 1? We want change in Y over change in X, or you could remember rise over run. I think we want the 3 on top, 3 over 1, which is the same as 3. All right, let's see, line C here. Let me pick one of these slope triangles. So my change in X is 2, my change in Y is 1. So for C, we're gonna have, what do you think? 1 over 2 or 2 over 1? So rise over run, so it'd be 1 over 2. Does that simplify, or is that just how it's gonna be? That's it, that's it. We could write it as a decimal if we wanted to, right? What is a decimal for 1/2? 0.5. We could do that. All right, here comes D. Ooh, we actually get to do a little bit of counting on this one. My change in Y is 2. My change in X is 1, 2, 3, 4, 5 spaces. So for D, my slope is going to be, is it going to be 2 over 5 or 5 over 2? 2 over 5, kind of? Or is it going to be neither of those options? Did I write the right answer up there for D? I made a mistake, didn't I? What did I forget? We forgot that it's a negative slope, right? We decided that one was going to be negative because it's going downhill. So don't forget, put that minus in there. Oh my gosh, it is like such a common mistake in Algebra 1, forgetting to put the negative in the slope. All right, I want to show you guys something really quick before we move on to the next one. Look with me at C. I chose this triangle over here. Would it matter if I had chosen this triangle here instead? It would still be 1 and 2, right? And we would still get 1/2 for the slope. Look up here though, don't miss this, please. You don't need to write this down, just watch. What if I were doing line C and I chose to do this triangle right here? I picked 2 points and I made a triangle between those 2 points. Am I going to get a different answer if I use that big triangle instead of the small triangle? What do you think? Let's see what happens. So my change in y is 3, my change in x is 1, 2, 3, 4, 5, 6. So my slope, if I use the big triangle, would be 3/6. Is that different from what I got originally? It looks kind of different, but it is the same thing, isn't it? Because we could reduce this. What can I divide those both by? If we divided them both by 3, we would get 1/2, and that's exactly what we got. So I've got a question for you. Does it matter where we draw the slope triangle? No, you're always going to get the same slope. Does it matter how big of a slope triangle we draw? No, you're always going to get the same slope. One last question. Does it matter whether I draw the slope triangle above the line or below the line? It's still going to be rise over run. This is 2, this is 4. If I made that slope, it would be 2/4, which comes out to be 1/2 after I simplify it anyway. So it really doesn't matter where you draw the slope triangle, how big you draw the slope triangle. You just want to pick some points that are convenient. So when we get to 26 here, we're going to have to draw our own triangles. I'll do A with you. I'm going to have you do the rest on your own. So for A, pick a couple points that look convenient. I don't know. I kind of, for some reason, I like the look of these 2 right here. So this is the slope triangle I'm drawing. But if you want to do another one, we just learned that it doesn't really matter where you draw the slope triangle, as long as you get your numbers in the right place and simplify. So my change in x is 1, change in y is 2. For line A, my slope is going to be rise over run, or change in y over change in x is going to give me 2/1. Ooh, is it positive or negative? Line A, is that a positive slope or a negative slope? Positive slope, so positive 2/1, so that's just 2. All right, I want to give you guys a couple of minutes, and I would love for you to find slopes for B and C and D and E, and then we'll chat about them. One of those is kind of tricky. We'll see what you guys remember about that. We'll come back together in about 3 or 4 minutes and compare answers. So if you're done with all 5 of those slopes, I want you to do me a favor really quickly. Could you go back and double check and make sure if there are any that are negative slopes, did you put your negative sign in front of your slope? It is so easy to forget to do that, folks. I can't tell you how many thousands of points people have lost on tests since I've started teaching Algebra 1 for forgetting to put a minus on a sign on a slope. And I'll tell you, it's not even just in Algebra 1. It happens in geometry and Algebra 2 and pre-calculus and calculus. Wouldn't you say that's like one of the big common mistakes? Yep, I do too. I do too. I've made the mistake so many times though that I've kind of trained myself to double check. So that saves me a lot of time. But I still make the mistake all the time. It's just that I have an instinct that like I always go back and double check it. I think half of becoming a good mathematician is not like, it's not that you stop making mistakes, is you just get better at catching mistakes as soon as you make them. Like, oh, I'm not getting burned by that one again. All right, so let's do B. I got to pick a couple points, and you might have picked some different points than I did. I'm going to go for these 2 right here. So my change in x is 2, my change in y is 3, and it's a positive. I would be walking uphill, so my slope is going to be 3/2. Is that what you guys got for B? Did you come up with 3/2 for B? Awesome. And then that gets us good with B. Let's see, for C, I might come down here and do these 2 points. Again, it doesn't matter which points you use. We should get the same answer. My change in Y is 2 and my change in X is 3. That seems like it's the exact same as what we just did. Or is it? Oh, it's different. They switched the change in Y and change in X, didn't they? It's still a positive slope, but this time when I do rise over run or change in Y over change in X, it's going to be 2 over 3 instead of 3 over 2. All right, D is this one here. So I'm going to go between these 2 points. My change in Y is 1. My change in X is 1, 2, 3, 4, 5. So change in Y over change in X, that's 1 over 5. Is that right for D? Oh, negative! You got me. All right, E is the weird one. Now, if I pick any 2 points on E, it doesn't matter which 2 points I pick. I should get the same answer. What is my change in Y between any 2 points on this line? 0. So it's going to be 0 over... Now, it's not going to be over 0 because these are not at the same place. My change in X here is 2. If you picked some different points, your change in X might have been 3 or 5 or something like that. But it doesn't really matter because what is 0 divided by anything? 0. So the slope for E is 0. If I asked you, is the slope for E positive or negative, what would you tell me? Neither. No, right? 0 is the only number that's not positive or negative. It's like right in the middle. All right. One last question, and then we'll take some quick notes in our packets. Look at these 3 lines and tell me which one's the steepest. If you were out hiking these 3 slopes, or sorry, these 5 slopes, which one would be the most strenuous hike going up? You think A? A and B both look pretty steep, don't they? You think A is definitely steeper? How can you prove it to me numerically? Ooh, look at you go. Okay. So you're telling me that B has a slope of that's equal to 1.5. 3 divided by 2 is 1.5, isn't it? Why does that matter? So you're telling are you making the claim that steeper slope means a higher slope number? Have you guys heard that before? The higher the slope number is, the steeper the line is. That's kind of what slope measures, is how steep something is. So does A have the highest value for slope? Yeah, 2 is definitely bigger than 1.5. 2 is bigger than 2/3. 2 is definitely bigger than 0. So A is the steepest, followed by B in terms of steepness and slope. All right, let's do some quick notes in our pack. You guys are doing awesome today. I appreciate your input. I appreciate your focus. We've got a learning log in our packet that says rates of change in slope. It's the first learning log. It's after the last problem in the packet. And we're going to take some notes right here on slope. We're going to be putting a lot of different things in this learning log, but for right now, let's just get a little bit of information about slope. So we often use M to represent slope. So I'm going to write M equals, and I'm going to write the little formula out, changing something over changing something. Now I got this wrong on the front page of my packet. Let's make sure we get that right in here in our notes. What goes on the top? Is it change in Y or change in X that goes on the top? Change in Y goes on the top. Change in X on the bottom. And for some people, it's easier to remember rise over run. So I'm going to go ahead and put that in my notes as well. So today we kind of learned about slope triangles, and then we just reviewed what a positive and negative slope looks like. So I'm going to go ahead and take some notes on positive and negative slope here too. So I'm going to draw a positive slope here. Now a positive slope would move from left to right. It would be going uphill. So I'm drawing myself an arrow that's definitely going uphill from left to right. And then I'm going to build a little slope triangle off of that arrow. And I'm going to label my two sides change in X and change in Y. Which one's this on the left edge? Is that change in X or is that change in Y? It's going up and down, so that'd be change in Y. And then this one's going left and right, so change in X. So there's a positive slope. And let's do the same thing with a negative slope. I'm going to draw another arrow. This time it's going to be going downhill as I go from left to right. And I'll do the same thing. I'm gonna build a little slope triangle off of it and label my change in X and change in Y. I think that'll probably do us for today. We'll add some more examples. We're eventually going to talk about how we find slope by looking at tables, how we find slope by looking at graphs and situations and everything too. But for today, let's just kind of dust off some cobwebs and we'll call this good. On Tuesday, we'll come in and we'll practice a bunch of slopes, drawing lines. We'll get into y-intercepts and all that fun stuff too. So, does anybody have any questions for the greater good before we wrap up today? All right, so let's just revisit our learning target. Do you feel confident that you can recognize a positive versus a negative slope? Are you feeling pretty good about that? Yeah. Do you feel pretty good about finding a couple points on a line and drawing a slope triangle? You think you could do that? Count spaces. And then once you have your slope triangle, can you make a fraction that's change in Y over change in X? If you're feeling pretty good about those, then give yourself a pretty decent score. I think a good score at this point would be like a 3. I think in order to score myself a 4, I'd want to have a whole bunch of practice so that, you know, when this, ask yourself the question, do I know this well enough that when I see it again next year, I'm still going to remember it? That would be a 4 out of 4. But if you're feeling pretty good about it today, then I'd say give yourself a 2 or 3 out of 4. All right, this, by the way, this isn't a grade. This is just to kind of give us an idea of where we're at. Now, if you're not feeling good about it, if you feel like you've still got questions, give yourself a 1. That's fine. That's fine, and we're going to slowly move that up. Okay. All right. That gives us a little bit of time here for assignments.